So in this video, we're going to get some review of factoring and our methods of solving quadratic equations. So when we solve quadratic equations, the first thing we should look for is a greatest common factor. So with this first example here, so I can tell this is a quadratic equation because I have my x squared there. I also have the equal sign, which makes it an equation. So first thing I want to do is typically get 0 on one side of the equation, which is already set up here. And then what I want to see is there's something that can be factored out of everything, which in this case there is. I can factor out a 3. And it's like I'm dividing 3 out of each piece, so that'll leave me with x squared plus x minus 6. And that equals 0. Now, in terms of factoring, that 3 is important. We could technically divide it out here. We could divide by 3 and divide by 3, and it wouldn't really change anything. I'm just going to leave it out front so we can see our common factor, but it's not going to change anything in terms of solving. Alright, so here I have a trinomial that I want to factor, and just as a review of our factoring methods, so this is a case where we have 1 in front of x squared, so I would look at the factors of negative 6. So I would have like a negative 1 and positive 6, 1 and negative 6, negative 2 and 3, and positive 2 and negative 3. And I want to see which of those add up to a positive 1. So I'm looking at the number next to x. So here I have 5, negative 5, positive 1, negative 1. So I want to use that negative 2 and positive 3. So for this method, I separate into my two factors. And I would have an x with a negative 2 and x with a positive 3. So here's my factored form. Now solving the equation, the rule goes that if we have pieces that are multiplying with each other, and if they multiply and equal 0, that means at least one of them has to equal 0. Now this 3 is kind of extraneous because 3 cannot equal 0, so that's where we're just going to kind of ignore that. But we should have x minus 2 should equal 0, or x plus 3 should equal 0. So this is where we split up our equation. So x minus 2 equals 0, or x plus 3 equals 0. And then we're going to solve these two equations. So x equals 2, x equals negative 3. And that's our two solutions to our equation. And then with these, you can always check your answer by plugging them back into the original equation and see that they work out. Alright, this question here, so notice that we don't have a term with y. If we think of our quadratic as ax squared plus bx plus c, what we're missing is this bx term here, and what we can use is the square root method when we're missing that bx term. So the square root method means we're going to solve for that y squared. So we want to isolate that first. So I'm going to add 25 to both sides of the equation. So I get y squared equals positive 25. And then what we can do is take the square root of both sides of the equation. So the square root of y squared is y. When we take the square root of both sides, it's super important to have the plus or minus. You have to have the plus or minus. And then square root of 25 is 5. So I can see is if we plug in positive 5, well, 5 squared minus 25 will give us 0. Also, if we plug in negative 5 for y, negative 5 squared in parentheses will be a positive 25 minus 25 to get 0. So we end up with plus or minus 5. And you can leave it in that form, or you can separate it as y equals positive 5 and negative 5. Either way. Alright, in this form here we can see it's quadratic. And what we need to do is get 0 to one side of the equation. So first thing I'm going to do is distribute 8 into the parentheses there. So we have x squared equals 8x minus 16. Then I want 0 on one side of the equation. Now I could subtract the x squared. However, it can be helpful to keep x squared positive. So because x squared is positive over there, I'm going to move everything to this left-hand side. So I'm going to subtract 8x from both sides. I'm also going to add 16 to both sides. So with that, on the left-hand side of the equation, we'll have x squared minus 8x plus 16 equals 0. And now we can factor. So again, the idea would be to look at the factors of positive 16 and see which two values add up to a negative 8. So if you list out all the possibilities, it's going to be negative 4 and negative 4. The idea that negative 4 times negative 4 is a positive 16, negative 4 minus 4 gives a negative 8. So I'm going to separate into the two factors here, and we'll have an x minus 4, x minus 4. Now, this is the stage where we separate, because the idea is that x minus 4 has to equal 0 or x minus 4 has to equal 0. Well, that's the same exact thing, so you only really need to solve one of them. So I'm going to say x minus 4 has to equal 0. So x equals 4 solves this equation. I want to show you another form where we have these multiplying with each other. You might also factor it and just write it as x minus 4 squared equals 0, and that works as well. Alright, some more examples here. So, if x squared is negative, then what we want to do is factor out a negative number. So I'm going to factor out negative 1, so that'll leave me with positive x squared minus 11x plus 18 equals 0. And like I was saying with the 3 in that first example, we could divide it out. We could divide out this negative 1 so it's totally gone. And it's just when you divide by negative 1 on the right hand side, it doesn't do anything because you have 0. Either way. So we want to factor that x squared minus 11x plus 18. So what we would do is look at those factors of positive 18 and see which ones add up to negative 11. And that's going to be a negative 2 and a negative 9. And then we'll see that x minus 2 has to equal 0, or x minus 9 has to equal 0. So x equals 2 and x equals 9 are the two solutions. Alright, so in here we can't do anything until we have 0 on one side of the equation, so my first step is to subtract 30 from both sides. 2y squared minus y minus 15 equals 0. So this is where we have a number out front. We have a number for a. And with this, you can do trial and error. You could just kind of keep plugging in values until it works. Or the method that I showed in our review that I'll go over here is the AC method. So the AC method takes our value for A, takes our value for C, and multiplies them together. So it's like a 2 times negative 15, which is negative 30. So I want to look at the factors of negative 30. So let's go ahead and write them all out. I know it's exhaustive, but just to really show this method, since we haven't gone over it in a while. So negative 2 and 15, or 2 and negative 15, 3 and 10, positive 3 and negative 10, or 5, negative 5, and positive 6, positive 5, negative 6. Alright, so I want to find the pair that adds up to negative 1. So I'm looking at B there, and what I'm going to see is, well, I'm going to focus on these negative 5 and positive 6. Negative 5 and 6 will give a positive 1, and 5 and negative 6 will give a negative 1. So I want to use that positive 5 and negative 6. So what I do with the AC method is that we're finding values to help us rewrite that middle term of negative y. So what we're going to do is take that negative y and split it into two terms. So we're going to keep 2y squared, stays exactly the same. And instead of writing negative y, what I'll have is positive 5y minus 6y. And then we still have our minus 15 at the end there, and then that all equals 0. So what we did is we just rewrote that negative y as this kind of separated, unsimplified middle term. Because if you take plus 5y minus 6y, you do get negative y. But separating this gives us our 4 terms, so now we can factor by grouping. So grouping method, we cut our expression in half. we look at the left-hand side and look for a greatest common factor. So there's a common factor of y, and that'll leave us with 2y plus 5. On the right-hand side, so because that leading term there is negative, our greatest common factor will be negative, and it looks like I can take a 3 out of both of those. So I'll have negative 3, which will leave me with positive 2y, positive 5. All equals 0. So to help visualize this, what I'm really doing, it's like on this left-hand side, I'm dividing y out of each term. On this right-hand side, it's like I'm dividing by negative 3 for both of those. So then what I end up with is this common factor of 2y plus 5. So I'm going to do is factor out the 2y plus 5. And if I do that, then I'll have this y left over and this minus 3 left over. And that all equals 0. So that's our factoring with the AC method. But that was all to factor it. I haven't solved anything yet. But now I have my factored values, and I can see that this has to equal 0 or this has to equal 0. So I'll have 2y plus 5 equals 0. I'll subtract 5 from both sides, divide by 2. So y is negative 5 halves. And then y minus 3 has to equal 0. Add 3 to both sides, y equals 3. So there's a review of our AC method and factoring by grouping to get to solving that quadratic equation. Last one here, this is that case where we just have t squared as our variable. So what I'm going to do is isolate t squared. So I'll do that by adding 4 to both sides. So I'll have 9t squared equals positive 4. Then I'm going to divide by 9. So we get t squared equals 4 ninths. Now from here, I can take the square root of both sides. So that'll give me t equals, and we'll have our plus or minus. And then the square root of 4 over 9, you could think of this as the square root of 4 over the square root of 9. So we can simplify that down as 2/3. So we'll have two solutions, positive 2/3 and negative 2/3.